I don't know what God has to do with this picture, but it is a very neat little geometric exercise to prove that this length is a square root of 2, this length is a square root of 3, and that length is a square root of 5. And can you find a square root of 7 anywhere in this picture? In this video, I'm going to prove that those lengths are what they say they are, so if you want to try it on your own, stop the video here and come back later. First of all, these are two circles, and they give me that the radius of the circle is 1. Since by the position they show, the circle on the left touches the diameter of the circle on the right, the distance between the two centers is a radius, so it is 1. And then the distance from here to the top of that circle is another radius, so that's another 1. Now, since the circle on the left touches the diameter, that means that this diameter is a tangent line to this circle, and therefore this line and that line are perpendicular, so that over there is a 90-degree angle. Therefore, the triangle with this side, that side, and this hypotenuse is a right triangle, and we can use Pythagoras' theorem. And Pythagoras says that the hypotenuse is equal in length to the square root of 1 squared plus 1 squared, so it is a square root of 2. Now let's go back to the drawing board and prove that this distance is a square root of 3. For that, notice again that the distance between the centers is 1. Also, the distance from that point to the intersection of the two circles is another radius, so it is also 1. And this is another radius, so it's also 1. So the triangle in green is an equilateral triangle. And now we can use Pythagoras' theorem to find the length of the height of the equilateral triangle, and that will be the square root of 1 squared minus a half squared, which is a square root of 3 over 2, a half being half of the base. And therefore, the length we were looking for, which is twice that height of the equilateral triangle, is a square root of 3. Back to the original picture, let's now prove that that is a square root of 5. For that, notice that the distance from this south pole to that south pole is also 1, and the diameter is 2. So now we have another right triangle with sides 1 and 2. And again, by Pythagoras, the hypotenuse is of length the square root of 1 squared plus 2 squared, so it is a square root of 5. Now, can you find a square root of 7 anywhere in this picture? Since we have found a square root of 3, a square root of 2, a square root of 5, playing with Pythagoras' theorem, we might want to try to find a square root of 7 in the same way. So you might want to, for example, try to find 7 as a hypotenuse, but 7 is not equal to the sum of two squares for any rational numbers a and b. However, 7 is 16 minus 9, so you might want to try to find a triangle with side length 3 and hypotenuse equal to 4, so that the other side has length the square root of 7. Where can we find a 3 in this picture? Well, from that side to this side is length 3. So maybe that's the base of our triangle. And it turns out there is a way to position 3 additional circles of radius 1 such that the length of the base is exactly 3, the length of that hypotenuse is exactly 4, so the length of the side on the right-hand side is exactly a square root of 7.